book giveaway. You can see I've got the as full of a beard as I can manage for the holiday season. And I've got basically I'm going to give away 5 copies of 5 little potions, which I've been working on for the last few weeks. It's about 40% done, and I finished up the second game in it. And today I'm going to show you the hardest part of that game, which is uh, basically a whole bunch of stuff regarding functions. Got anonymous functions that are creating functions to be used inside other higher order functions. It's not super hard, but it is a bit abstract if you're new to Elixir. So let's open up the code and make sure that everyone can see that. And here we go. So the most complicated thing, this is a tic-tac-toe game, but I did it in such a way that you can play any board size. So you can do tic-tac dot O to start as the O player, and we'll just go through a quick game here. Everyone just playing the simplest possible spots they could. Okay, it's a tie game. If we just change one variable, board size here, make this size 6, and I'll save that, recompile the game, and everything just works with a larger board, except maybe the UI. Maybe we need to give a little bit of information about what square number is what, but you see I put in square number 6, and we've got an O there. I guess I better make this a little bit bigger. Square number 36 would be the last one, square 1. You get the idea. So it's a very flexible setup, and the win calculation still works. So how did I do this? Well, obviously it's not hard coded in. What I did was I made some functions that just get lines from the board, and we've got a few different cases. It's going to be vertical checks to get a column, and horizontal checks, and then ascending diagonals, and then descending diagonals, like so. And there's a bit of information on each square. So we'll just say, we'll make a new square here, s equals square.new, and I'm just putting in a position number. You know what? Let me change the board size back to 3 just so it's easier to work here. I'll recompile again. Okay, so we make a new square in position 3. So that's going to be position 1, 2, 3. We expect it to be on the right side at the top. And punch that in. It automatically calculates the X and the Y from the position. That's just something I built into the square module. And then we can update the value of this to O. So right now the square is empty. Once we update this value, then it's going to be occupied by the O player. Oops, S equals. There we go. So now we have this square here, and if we had a whole board of squares and this were one of them, the board would now look like this. So how do we find if this play has won? Well, we need to check the row it's in and the column it's in, and we're just going to check both diagonals every time since there are only 2 diagonals on a board. Well, we've got this X and Y coordinate. That makes things a bit simpler. If something is on the same row, it's always going to have the same Y coordinate. If we had a square in position, actually I'm not going to set a square equal to it. I'm just going to create one here. If we had one in position 2, you can see it's got the same Y value as the one in position 3. So that would be right there. Okay, so if the Y value stays constant, if the square has the same Y value, we know it's in the same row. And similarly, if it has the same X value, we know it's in the same column. I'm just going to create a whole new board so that we can look at all the squares together. Board.new. And getting the diagonals well, let's see what the diagonals are. So we have position 1, 2, 3, 4, 5, 6, 7, 7, 8, and 9. So 1, 5, and 9 would be one diagonal. And we can see 1, well, that's x location 1, y location 1. 5 would be x value of 2, y of 2. And then this ninth position would just be x is 3 and y is 3. So the descending diagonal is just the squares that have the same x and y value. So square x minus square y equals 0. Or we could have just said square x equals square y. To get the ascending ones, well, let's see. This is in the first column, so that's an x value of 1, and it's in the third row, so y value of 3. And this would be 2, 2. And this would be 3, 1. So, or it'd be, 3, 1. So here we have 1, 3, 2, 2, 3, 1. Those all add up to 4. And whatever the size of the board is, they're going to add up to 1 plus the maximum length of the board. Like if we had a 6x6 board, well, then down here it would be 1 column 1 and row 6. So 1 plus 6 is 7. So whatever it is, it's going to be board size plus 1. So as long as the sum equals that, that's our filter. So filter is a function in enum we can use to filter out just the values where something is true. So let's open up the terminal again, and let's actually save the squares from this board. So we'll say squares, we'll just pattern match squares equals squares s equal, actually I'll just call it squares equals board.new. And now we can type squares and just get the squares here. So this is a list of 9 squares, and we can put those through enum.filter and just filter on the squares. Actually, I'm just gonna change that to I, just so it's not confusing with the coordinate to x. And if the position of, or say, if the x value of this square, let's call it s, the x value of that square equals 1, this will return true. And if it doesn't, it'll return false. And what did I miss here? Undefined function x, oh right, s dot x, be the x value on it. So now we've got just this set of 3 squares where the x value is 1 in all of them. So that would be the left column. And similarly, we can do that with y if we want to get the row. So now we have positions 1, 2, and 3. Y equals 1 in all of them. We have all the x's. So that's a quick way to get a row. And we've already made the function here. So I can just call it with the module name, which is game. So game dot make column. Actually, I can't do that because there's one more level of abstraction. So we'll just make a function locally here. We'll just say column filter 1 equals this anonymous function that we just pasted in here, or that I just typed in there. So that is column filter 1. And now we could just call this enum.filter with column or call filter 1. And gotta capture the function so we can pass it in as an, oh no, we don't, because I defined this anonymously here instead of as a module function. Okay, so that does the same thing we just had. It's a little bit easier, but there are 3 different column filters. We have to be able to get the column filter for, let's do rows because it's easier to highlight. So we have like row 1, row 2, and row 3. So what I did in this game is I made a make column filter function. So this function will make the filter function that gets a specific column. So what we need to do to make that is have a function that returns this anonymous function if it's the first column. So it's a function that returns an anonymous function. We take a position in, we just return this here. So we're still getting square.x of the position. This is comparing, this is, well, I'll just show you what square.x does. So square.x of 5 gives you 2 because the fifth position is in the first, it's the middle square. So it's got an x value of 2. So to create this function, we can just make another function. We'll call it a make. Yeah, we'll just call it the exact same thing we've got in the game. Make column filter equals, and it's got to be a function that returns this. So we have a function that returns a function that uses whatever position was passed in, and it matches the x value of whatever the x value of that position was. And returns it. So this is going to return the middle portion. And I can't do a def right. So function and position is not defined. Got a little syntax issue. Okay, there we go. So we've got make column filter, and we've already had our column filter 1 made manually, and I'll just make another column filter for the second column. So call 2 filter equal, or call filter 2 equals make column filter 2. I've got to put a dot here since I didn't define it in a module. It's just done anonymously here. And now we should be able to do that same enum filter we did above, except call column filter 2. And we've got the second column. So made a function generating function that will return the filter function for an enum filter to use. Then once we have all these filter functions made, then we can use those to get the specific lines that we want. So to check a line, basically to find a winner, like what we need to do is we just need to see if all the squares in that line have the current player in them. So it's just enum.all. And then if they do, then there's a winner. So to check all of the lines, we just want to find if any of the lines had a winner in them. And then finally, the win check uses that. There's some more information coming in on the game that's passed into these functions, like who the current player is, what the value of the current move is, that kind of thing. But the basic idea is all right here, and it's not a whole bunch of code, and it works on a square of any size. So that is what I wanted to show you. And I see there's one person here. Did you have any questions or comments? Are you an Elixir programmer, or just kind of randomly find the stream? Nope. Okay. Q&A is over, and I will see you next time.